Okay, I can see you now.
Hello?
Yeah, okay, I can hear you now. Now let's see whether the video works. If not, let's not troubleshoot. Let's do something else. Okay, video looks slightly better, right? Okay. Oh, very nice. Okay, please zoom in. Which one? Which one? Which is the question?
So it's one.
Okay, then zoom out a bit, just a bit. Just zoom out a bit. Okay, nice. Go down because I cannot see the top one. Maybe it's important. Okay, thank you. Okay, remove your hand. Thank you. Kindly drop down. Go down. Okay, make it go down a bit. Thank you. Right. Okay, I'll do that. Okay. Can't get all. So tell me what your question is.
Okay. I can write the equation for dissociation of water, like
Very
for
good.
the three acids. But
Very
I can't do it. I'm not sure how to do it for ethanoic acid. I don't even know they reacted.
Let me read carefully. Yeah. Okay. Yeah. I see. Yeah. So I just finished reading. So judging from the drops, right? Judging from the drops, the first acid stronger inside ethanoic acid, right? And the third one is not very.
That's not strong. Yeah. I know that, but I don't know how to prove it like equation.
Now, however, I am. Oh, okay. Now I confirm it's pure ethanoic acid. So there is no water. So it's not easy to. Let me clarify one thing first. Acids don't dissociate. Sorry. You cannot assume an acid dissociate, a strong acid dissociate, if it is not in water. Okay, you cannot. So, for example, your HClO4 in water, it will dissociate to H plus, that's a O level weight, or H3O plus, whatever, and ClO4 minus. That's in water. By himself, he does not do that. Can you accept that first? Do you find that to be like some sort of memorization, or is that something that you can accept already?
The HClO4 by.
Okay, I'm going to write something. So one more time. By himself, that means pure HClO4, meaning to say there is no water. No water. He does not do this. He does not do this. He does not do that at all.
Because
no chance that he's doing this. Do you know why? Because this dissociation doesn't happen if it is not in water. Yeah, but why?
I mean, there isn't a strong base to check them.
Okay. I'll put it another way. Okay. So AgNO3, right? AgNO3 is not acid, it's not base, it's just a normal salt, right? In aqueous, right? Just a normal salt, right? Ag plus and O3 minus, correct? Aqueous, right?
Yeah.
Aqueous. Now, and then you learn something else in O level. If you meet AgCl, even though it is aqueous, it is not, well, it's not aqueous, it's not dissolved, it's solid, so it does not become Ag plus and Cl minus, right? It does not become that.
Okay.
Right. Even though this is in water, let me just take forward. Even though it is in water, so it does not do that. Now they don't explain why. They ask you to memorize. They only ask you to memorize. Now,
like
you know?
solubility and all that stuff.
Solubility. So why is this guy, so to speak, not soluble? And why is this guy, so to speak, very soluble in water? Any idea from your A level? Any idea?
So I have to imagine that Cl minus is not a very strong base.
Not
like Ag plus.
But I'm not dealing with base right now. I'm not dealing with base right now. I'm dealing with non-salt. Right? I'm not dealing with a weak acid, weak base. Yep. You're saying?
Aside from like ionic bonding and all that stuff.
If you can say something about ionic bonding, that would be nice, because obviously there are ions here, right? Obviously, maybe you can say something.
I don't know. I guess the strong ionic bond, stronger ionic bonding, like in the AgCl.
Ag plus and Cl minus, right? Because they're ions, compared to Ag plus and NO3 minus, right? So that's what you're saying, basically. Now, I'll try to complete that. I'm trying to complete again, because maybe it's fine. Maybe that's already something from A level. Now I'm going to complete. I'm trying to make it better. Now, whenever I draw that, you know what this means, right? What does this mean? This thing is a shortcut.
The visa. I'm not sure. Actually.
Yeah, it's a shortcut for water.
Oh, water.
Water, because water is V, H2O. Yes, H2O. Okay. H2O, and then the Mickey Mouse or the V has a positive and negative end. So where's the negative end and where's the positive end?
Negative end is at the O and positive is at the H. So
right, that one no need to memorize, right? So when I draw that, that means there's your negative and there's the positive. Okay. Now I'm going to put this into the picture of the AgNO3, right? So the AgNO3 will have this, and the NO3 minus will, the water molecule is surrounding it. In fact, isn't that what it means to be dissolved? To be dissolved is to be surrounded by a water molecule in the ionic level. That's what it means. Look at the ionic. Look at the water molecule. The negative side is orientated into the Ag plus, and here the positive side is oriented to the NO3 minus. That's not an accident. The water will simply do that. The water can do that. Okay. So in terms of AgCl does not have this nice surrounding in water, because in the macro sense, in the big sense, the AgCl is just sitting here, right? Correct? Just sitting there. The water is here, but the water is not surrounding him in any meaningful way. It's just in the water, but it's not being surrounded, so to speak. Okay. So put it another way, the ionic bond between them seems to be stronger, much stronger, such that the water cannot kidnap them. Here, for some reason, it is weaker than the kidnapping power of the water. I'll just put it that way. The water is able to separate them. Here, the water is unable to separate them. They are stronger. Okay. Now, let's go to acid, what we're talking about just now. Acid, base, salt, same thing Acid is also ionic. Base is also ionic. Salt is also ionic. So when HClO4 dissociate in water, they are being separated, right? The positive is being separated from the negative. How does that happen?
Surrounded by water.
There you go. Right. Now this one is big, so it needs a few surrounding water. This one will attach itself to one water molecule and become the hydronium. This thing, no? Yeah, something like that. So that's what you learn in A level. So that's what it means. So I only need one water molecule to kidnap this guy, but this guy will also be surrounded. That's the reason. Okay. So far so good. Okay. Okay. So now, can you accept that if there is no water, then this doesn't happen?
Yeah.
They will simply stick together. because that's all they have. They have positive, negative characteristic. So they will not become acidic, so to speak. So theoretically, that's not what happened. They didn't become acid. So I have a practical question for you. Let's say you have a pure HClO4. Theoretically, you know that this doesn't happen. All these are gone. You just have this combined guy. So theoretically, he's not an acid because there's no H plus flying around. Can you safely put your finger into a pure HClO4?
Yes.
No, you are 70% water.
Oh.
The moment you touch the pure HClO4, it releases H plus because you are water. Ma. Remember that. Okay. Understand that? Just practical thing. So the moment he touches water, for example, from the surrounding air, it will already absorb that water. So a pure HClO4 doesn't truly exist. But if there is, then it won't be acidic. But then again, everything which is living, everything around us always contains some sort of water. Now, okay, so never mind that. So now we are now saying that we actually have pure water, pure HClO4, kind of, because you're putting it in pure ethanoic acid, which is totally theoretical. This doesn't exist, but let's say it exists. You have pure HCH3COH, which implies the HClO4 does not have any water. It kind of implies, so to speak, implies. So you have no water in this whole mixture. So judging from this, yeah, I don't think that is. I think the water is very small. I think you need to assume that, right? So when this meets that, somehow this happens somehow without the help of water. Let's just assume that for now. Without the help of water, this is happening. How can that be? It must be the CH3COO, right? It must be. So care to imagine how this may happen with the help of CH3COH, if it is possible?
See, my first thought was just the straight up the OH from the COH comes out, but I know that's unlikely to happen. Yeah,
because the OH will not come out. Yeah, no, because the OH doesn't behave like a base. It never detaches itself that way.
It's gonna be the H that comes out.
Yeah. So hey, it's acid and acid. Weird, right? It's weird, right? Acid and acid, right? What's our business in mixing acid, a pure acid, with another pure acid? A bit difficult to imagine, but that's what we are doing right now.
So, I mean, I imagine nothing will happen.
Right.
How do I get?
Yeah, because this question will not even test you on the K. Yeah, it's impossible. They don't test this normally in A level. He's just playing with you, lah. Definitely, he's just playing with you. For example, part 2, there is no calculation, right?
Yeah, it's just acid strength, but you know.
But you can already answer, ma. You can already answer, right? So for example, part 2, your answer will be.
In order of increasing acid strength, we'll start with HClO4, H2SO4, and then after that, H3PO4.
You're serious. The HClO4 is the weakest one. Serious.
Wait.
Serious. You're serious.
Wait, H3PO4 is a tri-basic. Okay, that might be around.
Look, arrange the 3 acids being tested in order of increasing acid strength. No, wait. He doesn't even say inside the ethanoic acid or in water. This question is not very nice. Eh? This question is not very nice. We're going to assume that this is being tested inside the ethanoic acid, right? That's what is being tested here. So arrange the 3 acids being tested in ethanoic acid in order of their strength. Who's the weakest guy?
HClO4.
And yet, it only requires 2 drops
to
produce sufficient ion to light up the bulb. It doesn't make sense. What you're saying doesn't make sense at all. Isn't acid strength proportional to its dissociation capability? Right? Isn't it?
I guess it is. Yeah.
Because HClO4 is not an acid until it produces H plus, until it dissociates. In other words, like seriously, you're gonna answer HClO4 as the weakest guy. Really?
Okay, maybe not.
Maybe not.
H3PO4 comes first.
Right, and then
Then
normally
H2SO4,
H2SO4 and then HCl. And how will you justify that? How will you justify that, right? Example?
Boy, I mean, I'll probably use like the data given, right? Because I'm not.
The drops, yeah, you have to use the drops, yes, but you have to use some justification, right?
But I don't know how to translate the drops used to produce sufficient ions into acid strength. Like, is it its ability to dissociate in ethanoic acid?
Yeah, that's the part that I feel you are not certain. I feel that you are not certain that acid strength is its ability to dissociate. An acid
I thought it was its ability to dissociate in water, which was
which is what we usually learn in A level and what is usually most important. I agree. This question is weird. I know. He's asking you to think in ethanoic acid, which is throwing us off. But that's what he's asking us to do.
okay.
Okay. So, but it remains, right? It remains. If you want it to be acidic, the acid has to dissociate. That's what they are testing you. Do you understand or no, YanKeen? They are throwing you a new context. That's just what exam do. But principle, you have to invoke a principle which works in a different context, but the same principle, the old principle, the principle that you learned beforehand. Let me say this very carefully. Yeah, the context is new. The answer is old.
Okay, I can work with that. I guess
there is a slight leap of faith if you notice lah. What you're assuming? You're asking me to assume that acid strength in water will be the same definition as acid strength in ethanoic acid. That's a slight leap of faith there.
Yeah, it is.
It is, but that's what exam do. New context, old answer. It's a matter of selecting the correct old answer. You have to do a little bit of faith there, but choose the least leap lah. Choose the smallest leap, so to speak lah.
Okay, I guess. So I guess.
Yes. Okay, please construct a sentence lah. Do some sort of working just lah, right?
Working. I mean, that's not. It's just writing. Isn't it?
All right. So you can write something first. You can say something first. But
in ethanoic acid, H3PO4 takes 25 drops to dissociate.
To produce sufficient ion, like you just have to quote the question, right?
Okay, to produce sufficient ions for the box to light up. How to make that connection? I mean, I can't just jump straight to it, which makes it the weakest acid. But
no, you can what?
But how do I?
You can what? You're quoting the data, right? First of all, you're quoting the data, right? And you are interpreting the data. You're not just quoting the data, you're interpreting that 25 drop is weakest. Let's just say that you're missing some of logic, but at least you are interpreting the data. You are adding something to the data. You may be wrong, you may be right. Understand? You're not just quoting the data anymore. You're already interpreting. You understand? Huh? You may not be able to justify, but still, you're at least doing the first part. You're at least arranging the asset. At least. Okay. Okay. Right? That's the minimum what you should do in exam with this kind of new context, old answer thing. If you feel that, then I cannot write a very proper sentence here. Then at the very least, at least do the interpretation. At least, because your first interpretation like totally wrong. I don't get it. I don't get why you can say HClO4 2 drop is the weakest. That bothers me a lot. You seem to be bothered by the fact that you cannot construct a nice sentence or justification. I am bothered by the fact that your first interpretation is just what? How did that happen?
Right. So I just say since at PGPO4 requires 35 drops for there to be sufficient ions lighter, Bob is the weakest acid.
Then H2SO4 and then HClO4. That's the minimum that you can do lah. Because you cannot even imagine what's happening in the ethanoic acid because you cannot do part one. Right? How does ethanoic acid influence this? Okay, that's the new context. I cannot imagine that, but at least I can get 1 mark from here. At least, okay.
Yeah. Okay.
Now let's go to part 3. Interesting, huh? I'm ignoring part 1 for now. Now the acid under test is more or less fully ionized in aqueous solution. Which acid are we talking about?
The acid under test. I guess
all, or I suppose all three because I'm a bit confused with the sentence. Why is it singular? But okay, I guess it's all three, right? Because all three are very strong acids. I guess that's the knowledge test. Do you know that all these three are super strong acids? Right? Okay, let's say you know. Now, suggest why there's a difference in terms of relative strength of water and ethanoic acid as bases. Right now, this is where you may want to say something. Can you say something here?
I think water is the stronger base, isn't it?
If water is the stronger base, then what does that mean?
Well,
if it is a stronger base, then
if it's stronger base, then word, it's more readily, it readily accepts
the proton.
The proton more easily than ethanoic acid.
So it's a stronger proton acceptor. Therefore, it forms the H3O plus, right? H2O plus.
Yeah, and
ethanoic acid
are more fully ionized.
Right. But ethanoic acid doesn't seem to be a stronger base than water. Heck, it's even called acid, right? Right. Why should I be surprised, right? So he is actually suggesting you to view ethanoic acid as a base, meaning to say as a proton acceptor. It's weird, right? It's weird, you know. It's extremely weird. He is asking you to do that. I am saying to you, he is already giving you a hint for part 1. As weird as it may be, you are to view ethanoic acid as a proton acceptor. It's super weird.
But where? Okay, then my question would be, where would it belong? Where would it go?
I mean, water doesn't like the water doesn't dissociate, right? When he's accepting the H plus, right? He does not, right? So he just become H3O plus, which is, if you want to say, it's also something weird, right? I mean, what is that? A water molecule with a proton attached. Okay, I'll entertain that thought loop somehow. So he's basically asking you to view ethanoic acid as accepting a proton.
Okay.
It's accepting the H plus. That's the part 1. I think that's the hint. I think. I'm not so sure. Remember, I never studied chemistry in uni, but that's how I read this question.
All right.
Now, in terms of part 3 is the why, right? Not that I'm supposed to do that. Part 1, I think I'm supposed to do that. That's why I say part 3 gives you a hint on part 1. If nothing else, that's what I'm going to do. Part 3 is the why. That means it's a guess, no? I'm going to guess why water is a stronger base than an acid. That's not going to be very hard. I think I can write something. Don't know whether that's going to be correct. Right? If you get what I mean. Right? So maybe you can say something about 1 right now, and maybe say something about 3, and then just be done with this. Right? Because all of them are guesses. To be fair. You will not find this in your note lah. Okay.
Definitely not.
Yeah. Go ahead. So make your educated guess.
So if I think of ethnoid acid as a base.
Proton acceptor. As a proton acceptor, yeah, you can write an equation, I suppose, right?
I mean,
As weird as that would be lah. That's it. I don't even know where the H will be attached to be fair. But that's the best guess I have. That's the best guess. Okay. Now, part 3. Maybe you would like to venture a guess and then.
yeah. Okay. So since water is a stronger base.
No, why is water a stronger base?
I mean, then ethnoid acid. I mean, it just is, isn't it? It's like
yeah, justify lah, right? Justify why, like, it's a weird question, right? Justify why water is a stronger base than acid. Okay, isn't it obvious, right? But okay, you want a justification, right? I guess give him some lah.
I mean, acid is less readily accept photons. I mean,
yeah. I mean, I want to say that, and I think about that, and maybe I can do something better. Like, I will quote KB, like, where we've been discussing this for half an hour. I'll be quoting KB. The KB of water is 7, right?
KB of water is, yeah, I get the P.
The P, sorry, the sorry, the POH, right? The POH of water is 7, right?
Yeah.
Right. So the KB is 10 to the power minus 7, sorry. So, but the POH of ethanoic acid will be lower or higher than 7.
Higher. No.
Will be
higher.
Higher, which means it's weaker, lah, right? Which means it's weaker, lah. Maybe I'll quote it like that. Maybe, it just feels slightly better, but I'm not really sure. I'm just doing my best here to justify.
Wait, let me find another pen.
Yeah, don't take my answer too seriously. Do you understand? I am also just guessing. Do you understand?
Oh.
Do you understand? I am not 100% sure. I mean, I'm not a chemist. I don't have the answer key. I'm just doing what the question is asking me to do my best guess. Believe it or not, that's what the question is asking you to do. I am, if you notice, however, I'm answering the question using my old knowledge, using my A-level knowledge. They're throwing me a new situation, but I'm answering using my old knowledge. So I never answer using any kind of a new or exotic knowledge. I didn't do that. Just want you to understand. Right now, if you don't have an answer key, we don't take this too seriously. We just let it go. That's all we can do.
I think I do have one target to pick it up.
Right. So you check it out either now or later. Okay.
Yeah.
But again, before you write my answer, which is you shouldn't take too seriously, it's just a nice guess. Check the answer key as well. Okay.
Yeah, let me go. I don't think it will take long. It's one of my files. finish this question.
Sure. Touch.
Right, let's check. Yeah, got it. Give me a second. Right.
Right. It's question 1A. Such a weird thing happened.
Yeah, there you go. CH20, H2 plus. H2 is stronger base, except
This is the part that I dislike. I dislike your sentence here because you never say except proton. You never mentioned that at all. Mentioning weaker base is the same as mentioning stronger base, but you never mentioned the direct simple application of a stronger base. Yeah, accepts proton more readily. That part I dislike.
Okay. Yeah.
Because I've been saying that, like I say that like 5-6 times. Okay. Now, let me tell you my emotion when I look at this answer key. Let's say answer key I consider like a chemist, like, a chemist knows everything, right? Because I'm not a chemist. Huh? I see this, I'm not actually happy with my guess. I'm just glad. I'm not happy that my guess seems to be correct. I'm just glad that my guess is not wrong. Do you understand what I'm saying here?
Yeah.
Okay, I hope so. Because I hope you understand. It's just a guess. I didn't actually know the answer. I never knew this before. I'm just making a guess. An educated guess lah, if you like. It could have been wrong. Could have been right. Did my best. That is, I believe, what is asked by the question of me lah. That's what I believe lah. I think that's the mentality you need to have when you're faced with, new context, but you suspect this is old principle. You should be suspecting that all the time, by the way, in exam. Oh, the answer is in my hand, but it's just that the context seems weird.
Okay.
That's the mentality. Right. Okay. So remember, I'm not happy. Wow, I'm so cool. No. I'm just glad I'm not wrong. Still, the answer key might be wrong. Right? Okay. So next question, please.
Yeah. Okay. Give me a second.
Must zoom out. Okay.
Where did I? Okay, it might be a bit simple. It's just like one part of a, but I wasn't too sure.
Is it question 8? Too much?
It's just 8 part 1.
Sorry, zoom out a bit. It's
just 8 part 1.
Okay, zoom out a bit. Zoom out a bit. Too much. Okay. Too big. No. Go in the middle. Don't go such extremes. Okay, nice. Okay, thank you. Right. Okay.
Yeah,
so this is
right.
Uh-huh.
Right. I'm not sure if okay, I'll jump to this. I'm not sure if I can just directly say that I'm not sure I can just directly plug this concentration into the equation. Because it has three H's instead of one. So
sorry. You're saying that you cannot do part 1, like A1, is it?
I can do it, but I'm not sure if I did it right.
You're asking A1 lah.
Yeah.
Okay. What does the pH value of 2.2 Represent. Okay, right. Okay.
Oh,
so,
no, not A part 1, just A part 2. A part 2.
A part, I'm sorry. Okay, A part 2. Calculate the initial pH. Okay, that's why. Okay, understand. Now I understand why you're asking. Okay. For folic acid at E. Now at E. Oh, I understand what you're saying.
Yeah, I mean, it might just be momentary, but I wasn't
You
too
are
confident.
supposed to have a K here. You cannot do anything without a K.
No,
Is it given? Is it?
no, but H3PO4 is a strong acid, isn't it?
Yeah, I mean, a strong acid, it is. Oh, wait. Let me think for. Let me think for. You're assuming full neutralization. You're assuming full dissociation of the phosphoric acid, and then you're asking whether it is ×3 or not. Basically, that's what your question is, right? Is it ×3 or not? Is the concentration of the H plus ×3 or not? Since this is a full dissociation, it is like. Oh, wait. You're assuming that, right? Are you supposed to know whether it is a full dissociation or not? Are you supposed to?
I mean, they're just asking for the beginning, right? So there's only H3PO4 in the solution.
Wait. Is the detail? Wait. Are you supposed to know this detail? Sorry. I'm gonna check it. HBl4 full dissociate. As far as I can tell, he does not full dissociate. It's not fully dissociate. Yeah, something just don't say, right? Okay, we're going to do a simple assumption. They all fully dissociate. So that's the answer. No? So is it going to be ×3 or not based on that? YanKeen, are you there?
Yes, I'm there.
I was saying, sorry. Did my audio cut off? I was saying something.
We're gonna do a simple experiment, then after that, just.
Oh, it was cut off, right? This is what I said. So the H3PO4 is assumed to fully dissociate.
Yes.
Meaning to say, your concentration of the H plus will be 3 times the concentration of the original acid, because dissociate 3 times.
Yeah, okay. I get that.
Okay, I think, okay, so I'm giving you the assumption to answer your question. So that should influence your pH. Influence your pH. That's it.
Okay. I think about that.
Right. Okay.
Right. It's like most of it.
Really? No physics question?
I mean, I have. It's like.
Last question. Then we'll take a break first. So a short break.
That's it. Okay. See, I'm not sure if it's something that it's something that's in like just show up in the notes.
Kindly ask.
This is for double slit.
Am I supposed? Can I just read the question? The context, the question above.
Yeah.
Oh, okay. A simple double slit, right? A simple double slit. So he's saying that he wants a brighter fringe because he has difficulty seeing it, maybe. And then to do that, he widened the slit. I think the logic is that you have a bigger hole, you let more light in, so whatever you see should be brighter lah. I guess that's the logic of the student lah. Can it make sense? Then he did not say that the thing become less bright or didn't change in brightness. The question didn't say that. The question simply say you don't have any fringes anymore, right?
Mhm.
So I'm giving you a lot of hints here. I don't know whether you already have an answer or not. If you have an answer, you give it to me because this is not very far from what your knowledge is. I'm giving you the first hint. The first thing is it's not that it doesn't become brighter. I think it does become, but the problem is there is no more fringe.
Is it? Is it that?
Why did the fringe happen in the first place?
Because there's constructive and destructive interference at certain point.
And you will notice that the interference happened because we're tracing back. The interference happened because of
interference happens because of the what?
The light from the first slit, say,
and
somehow meets the light from the second slit. Somehow, right?
Yeah.
Please notice very carefully that if the slit is super big, like it's a big hole, what will you see on the screen?
If the slit is super big, I would see diffraction pattern.
Nonsense. You're nonsense. You
I
don't
mean,
get
like, if they're like big enough, right? Like, but
if they are big enough, you see diffraction pattern. Like, no, that's just totally wrong. So I'm going to put the hole as super big. Like here is super big hole. Right? It's a hole. Okay, that's a super big hole. And then you're shining laser light. Okay, what do you see here? Again, you see diffraction pattern. That's what you're saying.
Where?
On the screen. Jamboard, page 9, sorry.
No. Where's the hole?
The hole is now very big. See? The hole is now very big.
Like,
are you seeing page 9? Sorry. Oh, yeah.
I see it is.
The hole is now very big, right? What do you see on the screen? Let's say it's a blue laser. Let's say it's a blue laser, right? Let's see. No idea. Let's just go straight. Yeah, let's just go straight. You will see most probably a blue dot here and a blue dot here, and that's it.
Oh.
What else could it be?
But
do you have a laser? Do you have a laser? Do you have a laser in your house?
No, I thought.
Like my point is this. You know that those small lasers, like you press, then the laser goes up. You know that, right?
Mm-hmm.
It's called a laser pointer. Maybe your teacher use it. Maybe you use it before, a laser pointer, right?
Yeah.
Does the laser pointer produce a fringe when you on it?
No.
It produces a dot, right?
Dot.
Laser pointer, the dot. The dot is not a fringe. To be very clear, there must be a hole, right, on the front of the laser to allow the laser to go out of the device. There is that hole, right? It must be, right? Yeah. So here's the laser producing stuff, and there must be a hole in front of the device, and therefore here you have a pointed laser, a laser dot. So the hole must be what? Super big, super small, just the right size in order to simply produce a dot. Yeah, do you have any idea?
Just no, it's bigger.
Yeah, big. If it is a big hole, which the laser pointer does have a big hole, it doesn't care. It's just a hole. You can see the hole. then the product is just a dot, just as big as the laser ray, the dot. Put it to say, if the hole is very big, there is no fringes, there is no fringes. Why is that?
I mean, I guess because there's no diffraction.
If there is no diffraction, the light from this guy will not do that, right? That's diffraction, right? Remember, diffraction is spreading,
like
not in a good way.
Yeah.
So if you have spreading, then you have a chance that the first guy and the second guy will interfere. Then you have a chance of interference pattern. No? But if the first guy and the second guy does not spread, i.e. does not diffract, right? So they don't interfere, no? So they just appear as two bright dots. That's it.
Oh, okay.
It's brighter, but no interference, no? Because I cannot interfere. I'm not spreading. I cannot reach you. You cannot reach me. Okay?
Oh. Okay. Because well, my notes didn't make this very clear, like relating diffraction to double slit. I mean, kind of did, but like only in the diffraction part. Like the double slit part doesn't mention diffraction. Okay.
Yeah, but double slit have diffraction, right?
I guess. Right?
Because that was because whether double or single, if the slit is small enough, it will diffract, right? That's the principle.
Yeah.
Isn't that the basic principle? Oh, but if it spreads because it diffracts, then it can interfere. No? Then you have a double slit case. This is a basic foundation. Please understand it that way. This is the foundation. Right?
Yeah, I guess I always thought they're separate things.
Yeah, please don't. That means this gap is being closed. You shouldn't have that gap. You shouldn't be.
Okay. Yeah. Right?
So let me just reiterate the principle. The principle is that the slit size matters, right? That's the principle. If you have a small slit size, you have diffraction. We'll talk about that. If the slit size is big enough, you have very little diffraction, so to speak. So small, it is unnoticeable compared to the brightness. Okay, any other question? Now, it's a good question. You're wrong. It's a good question.
Yeah, not for now.
Okay. Now, we end at normally we start right now, right, and then we end at 7:30, right? So we'll take a 10-minute break and then we'll resume again. And you're saying that there are no more honest questions, right?
Yeah.
Now, so that it doesn't bother me. You start studying today, like I think about after lunch, maybe 1 or 2 p.m. Correct?
Yeah, around there.
Didn't you try to do questions?
I mean, like some of the questions I can, like some of the I didn't do a lot. I did like practice questions, and like some of them just refer back to the notes and just like it's like okay, so the questions were like just apply formula here, put definition there, stuff like that,
And then you're correct. I just want to check that you check the answer key You did
Yeah, but then I went to sort of like question like this. Like I went to it's like UIS stuff.
Good. So
I went to that for
the reason why you don't have a lot of honest questions is because you can answer those questions.
Not that I can answer. It's just they weren't very. I feel the ones that I tried weren't very in depth.
Correct.
Then when I went to the in-depth part like this one, in-depth part this one, then I had questions.
Right.
Which is like
Right. I suppose the only thing to fix from that, because we're talking about an exam which does not give you ample time to prepare. We're talking about that, correct? We're talking about exam where I'm supposed to study something of the past, so to speak, review, but yet I'm still studying something new also. It's a lousy exam. Truth be told, most people cannot do it well. They just half here, half there. As a result, most people are not productive. Right? So I'm trying to improve your productivity when they give you a lousy schedule like this. Right? I mean, as much as possible before tuition, jump into the as deep as you can, not the deepest, but as deep as you can. Your instinct will be to start with the easy question, because where else to start? Nonsense. The schedule is already nonsense. It's not you which is nonsense. Normally, if you're preparing for A level, you should do that lah. Just go slow and steady lah. You're revising, man. This one, the schedule is nonsense. You don't have much time. Jump into as deep as you can to extract as many questions. Don't know how many times I have to tell you this. You're not comfortable getting questions. You don't hunt for. You let it come to you. You don't go and hunt for your own question. That's the habit that you have to do. You don't have it yet. Understand?
Yeah.
Because the schedule sucks. That's not your fault. And you have tuition, which you can make use of, but you're not making full use of it because you're avoiding the deep ends. Okay? Yeah. The exam will not give you easy questions. Right?
Definitely not.
Right. So, but in this break, don't do that lah. In this break, just take a break. Okay? And then after break, we'll just go and hunt for them. Okay? Okay? See you in 10 minutes. Bye.
Thank you. Bye.
Shopaholic, whenever you have somebody
Hello, YanKeen, are you there? Hello, YanKeen, are you? YanKeen, are you there?
Hello?
Oh, yeah, okay, right. Okay, cool. So just a small break, and then we will finish up at 7:30, lah, right?
Yeah.
7:30, right? So, just to confirm, is there anything better to do right now than hunting questions, going to the deep ends?
Most likely no.
Right. Now I'm giving you one more thing to do during this crazy time, right? Just one more thing. Why is this a crazy time? Because the schedule is not giving you time to prepare properly for exam. Right? That's not appropriate. A level, you know that they're giving you a lot of time to prepare, right? Like almost 2 months just for preparation. Right? It's a totally different experience, right? Right. So in such a situation, I'm asking you, you should do a slightly crazy thing because it's a slightly crazy time. The slightly crazy thing is you should be hunting for question by going to the deep end, not waiting for the question to come to you. That you can do during A level, right? Here's another slightly crazy thing. You have the answer key, right?
Yeah. What's up with them?
Right. So this is crazier than what I suggest you to do. That means it's reserved for the time where you don't have much time. Right now, you still have some time, but maybe later at night or tomorrow, you'll think, my goodness, I don't have enough. I don't have any more time. What shall I do in this remaining 1 or 2 hours? You may think that way, right? Rather than being frozen, you should look at the question and then you should read the answer and see whether you understand them or not. Right?
Okay.
Right? That's even crazier, but we do that because times are crazy. Right now, you don't have to do that. Have you tried doing that before?
Sometimes when I'm rushing.
Right, when you're rushing. But let me tell you how to do it properly. You read the question, you read the answer, correct? You note whether you note where things are easy or where things are doesn't make sense. You take note. If you have tuition, you can ask them. That's also hunting for question. After that, you're supposed to close the answer key and do the question. If you cannot, then the answer key has no meaning. Okay. If you don't do the last step, then you're just reading your notes. Reading your notes have not a lot of value for exam because you're supposed to apply them. You're reading the answer key. That's a good note lah. Let's just say, oh, the answer key is a very good note. It's answering the question. But if you don't close it and you don't redo it, then you don't even know whether you understand it truly lah. Okay. So at least you do that lah for the crazier times. Now, right now, you review your situation now. This is slightly crazy or this is crazy. If it's slightly crazy, you just do the question normally, but go to the deep end. If this is already crazy, then you read the answer key and then close it and try to do it.
I mean, I think crazy comes tomorrow.
Okay.
When there's
So
like 1
today,
day left.
all right.
So
So
now-
today,
Friday, yeah.
right. So please hunt for questions. I'll be following your working. Right.
Yeah, okay. I think I'll start with some of the directing stuff as well.
Sure, but please open the video. Yep. Question?
Can you just, I'm not sure what like the specific question. I guess I'm just like not sure whether the method what I'm doing here is like right.
Okay, I'm just going to take a picture. Yeah, okay, it's okay, it's okay. Right, so reading the question doesn't seem that there's anything out of the ordinary. So you have the wavelength, you have the diffraction grating, you have the 750 lines. That's what we need from diffraction grating, and I think you're using the correct formula. Right? So now determine the angles of diffraction and which maxima of diffracted light are seen.
I don't. Am I mixing up? Because
first of all, I don't understand why they ask maxima, but your formula somehow changed to minima. I'm not getting that.
yeah, I'm not sure if I can because like because like I'm not sure where. I don't know. I thought I was. I thought I was trying to like find like the minima first and then minus away and then like find the back. That's where the maxima lies. I don't know.
And which maxima of diffracted light determine the angles. Oh. Okay, so show the original formula, please.
Oh,
Show the original. Yeah. There you go. Yeah, you write it down, please. Write it down, please. On your yeah, on that. Yeah, right down on the left. Yeah, that's nice. Now, what is the N for?
The order, I guess.
Right. So first, second lah. That's your 1 and 2 lah, and then 1 and 2 and 3 lah. So his question is like this. For 3 marks, determine the angles at which the maxima. Which maxima does he want?
All no, not
Yeah. All of them. Right. All of them. So he wants all of the angles of the maxima lah. I'm not sure where the minima is coming in right now, but I'm clearly reading the maxima, and the formula is for maxima also. Am I correct?
I mean,
the formula is for maxima. What do you mean by you guess? You should know by now, just read lah.
Well, they don't explicitly say it, but it's like angle between incident beam and diffracted beam, which I guess is the maxima.
Sorry, you're saying? How does the note say? Sorry, angle between.
The theta is just the angle between the incident beam and the diffracted beam. I guess that's maxima, but like they don't explicitly.
Oh yeah. Incident beam. Beam. Yeah, you say beam lah. I suppose that's maxima. Right, yeah, so the formula is for maxima lah, not everything else normal. So you rearrange into sine theta, right? Sine theta equals to n lambda over d, and then you make the sine theta into equivalent to theta lah. Am I correct? For small angles. That is not small angle.
I don't think I can apply the small angle. Right?
Yeah, this is not a small angle. Okay, can I see the formula one more time in your note? Yeah, we cannot. Yeah, we can. Okay, let me check the number one more time. Let me check. As in, no, let me see the question one. We may have a problem. So sine theta equals to n lambda over d. Now, let me check one more time that the lambda is 10 minus 7, right? So 5.9. And then the d, give me what is the d? The d is this 1.33 dot 10 minus 6. Let me think for a while. This is supposed to be small. No, this is, oh wait. Yeah. Yeah. Still, it should be smaller. No.
I don't think
It feels smaller than 0.45, so I'm just going. Just gotta make sure, right? Oh, it is. It is. Yeah, I'm not sure why, but my one is 0.44 lah. That's not a lot of difference from yours, but yeah, there you go. Now let's do that. Oh, whoa. Sorry. So tell me, how? Oh yeah, there you go. That's the number lah. That's the number here. Now I'm not sure how this gets to that. So what's going on here? Sorry. How did that happen?
where.
Like this is 0.44. This is around what I get lah. I'm looking at this number, right? How did this number become that? I'm not getting it. What is this?
Oh, that's. Oh, sorry.
Because sine
This
theta is
went to here.
this.
Sorry, this
Because
went to here.
like because sine theta is this, so theta is that lah. Is that what you're saying?
It's like that. Sine theta is this, so theta is that, and sine theta is this, so theta is that.
Oh yeah. That makes more sense lah. And we cannot double it. Yeah, because that doesn't work for diffraction grating. What's going on here? You need to sine inverse everything. And if you need to sine inverse everything, the n cannot. So right now, without any other information, this is the best thing that we can do lah. So the angles he want a summary of 1, 2, and 3 lah. I don't think this is minima. Yeah? I think that's a maxima, right? Okay.
Yeah, I think that's my fault.
So the angles will be sine inverse. We can assume that it's small. So n, right? N of 0.44 lah, right? I'm using this number lah, right? Something like that lah. Right. So this is what I'm going to write for the 3 marks. If I don't read the question wrongly lah. I don't think I read the question wrongly. Right. So and then I will explain n is 1, 2, 3 ... n is the order of maxima. That's it all. I'll have to include that as an explanation.
Okay. Right. Sure.
Yeah. That's okay. Right. Right. Yeah, I think it's the right thing to not assume. Yeah, okay. Right. So next question, you can read the answer key now or later. Okay. Next question.
Yeah, sure. Okay, what's this? Oh.
The diffraction grating is now rotated to a small angle so that the incident light is smaller. Oh, right. Okay. Yeah. So if I were to draw that, so normally it's like that, right? And then suddenly you rotate. No matter how you rotate, you will get an angle which is now no longer 90 degrees, right? So I'm gonna pretend that it's rotate. Wait, it matters, right? Yeah. So I'm going to draw it this way. This is no longer 90 degrees, and the grating looks like this. So I'm illustrating the grating. So this is now 90 degree plus, and this now 90 degree minus, something like that. Okay, so that's for our drawing and our notation. Right, make sense of what? What I'm trying to say is you should expect yourself to at least understand the question, right, in exam. So again, do you understand what they're drawing?
Like the plate will rotate like Like that, right?
like in the way of that arrow, right? There's a moment arrow there, right? So you rotate that way,
Yeah.
right? Right. So what I'm drawing is I'm trying to do that, right? As the grating rotate like that, the one part will be closer to the line here, and then this part will rotate away from the line. So negative 90, positive 90, with the grating line aligned like this. Now, does this make sense according to the question?
Yeah, I think it does. Yeah.
Okay, yeah,
Yeah,
because
so
if
it's like
you rotate more, then this will kind of like go closer here.
becomes like, yeah, like that.
Yeah, right, like that. So it'll become more and more and more closer, right? So we just say less than 19, bigger than 90, right? Okay,
Right.
Just to be clear, normally a normal diffraction grating does work like that. It's like that, no? 90 degree, 90 degree. Just to be clear, that's a normal diffraction grating. The line of the grating should be like this, because double slit is like that. Okay, clear, yeah? Just to be clear, right? Okay, so, right. Okay, so we have a nice picture, and the reason why I draw this picture is because I think it's slightly easier to understand than the picture they are drawing for us. The picture they're drawing for us, we have interpreted through this, right? So he's saying that the resulting diffraction pattern is no longer symmetrical. I wonder what that means, right? So suggest qualitatively any other effect on the appearance of the diffraction pattern produced on the screen, right? For 2 marks, right? Okay. Now, needless to say, this is new context or principle, I suppose.
Can
You're
you
saying?
can you give me a sec? I need to
right.
So I don't know how to explain this. I need to stop the Zoom call very quickly.
Okay,
yeah.
so go ahead. Yeah, go ahead. I'll be waiting.
Yeah, give me just 15 seconds, 20 seconds.
Yeah.
It's like,
yeah.
Hello?
Hello. Yes, can you hear me?
Yeah, okay.
All right. So I haven't seen the video. The video is now in. Just a minute, YanKeen. Air dong, air buah. Jaga-jaga aja. Boleh juga buat sarapan aja. Buat sarapan. Yeah. Okay. So yes, yeah. So we are here in this question, right? So can we say that this feels similar to the chem question? This is a new context, but hopefully the answer is old principle. In fact, I think the answer can only be old principle. I don't think we can answer something new, right? So the context is new, so we have never seen this before, right? So let me say a few things. If you just want the answer, you look at the answer key, simple, because this is new, if you just want assurance of the answer. However, I'm going to make a guess here. I'm guessing that this will not appear in exam. This will.
Yeah, I doubt it.
Right. Do you know why? That's a good guess, at least that's a good guess.
Because it's very unique.
And therefore, the uniqueness of the question is the uniqueness of the question. If they ask this again, it loses its value. So what is the value of this question to the examiner actually?
I mean, it's just to get the people who know the thing better, I guess.
I cannot say for sure, but I believe you're wrong. I believe the value of this thing is not to test whether people know, but to ask people to make educated guesses. Just like the question. Just like the game question. That's why it will never come out again, so to speak, because people already study it in the TYS, and it is not strictly speaking in the syllabus. It is intentionally not in the syllabus. New context, no? Do you understand? So a good guess is that this will not come out. Something else will come out, something else new. The last part of the question is just the normal part where they ask you this kind of thing. And the part will feel like this, look. Hey, this is not in the know. Hey, this is something new. Hey, this is not something I've studied before. And I am supposed to guess. The fancy word for this is induction question. Inductive question, sorry, inductive, not induction. Inductive question. You're supposed to apply all principle in a new context. Voilà. So now,
I've heard that before.
What do you want out of this question? Do you want to know the answer? Just look at the answer key, because I am going to make a guess here. What's the value to you? What do you want to get out of this thing?
How the principle can still apply even to like a new sort of condition changing, I guess.
You want to practice that, is what you're saying, right? You want to practice
because
that.
like they have like my notes have like a big list of like conditions that can occur and then the changes that will happen appropriately. So I guess it's just another way to see like how the principle will react to new conditions.
If your note has that, maybe you should at least refer to that and see whether there's a direct answer. If not, then
that's this. I've never seen this before.
Okay, then if the value of this question is only 2 marks, by the way, it's only 2, right? If the value is that you want to practice guessing, basically, right? Practice guessing, then if that's the value to you, then let's start guessing. Okay, how can we guess? What can we apply here? How to do it? How does the angle affect, right? So let's try.
Okay, so if it turns
right, it turns
like that. Okay, let's just say like that, right?
I mean, yeah. So I mean, yeah. I'm already drawing it.
It feels like a polarizer. So that means there must only be like I guess like the horizontal. I don't know how to. There's like less space. Yeah, the right word.
Less brightness, you mean?
Yeah.
Because the intensity of the light going through is being cut off more, right? I mean, I want to say something very clearly first. The diffraction grating is a polarizer. I don't know why they don't say that, but it is a polarizer. It is just a slightly different polarizer, but it is a polarizer. It will polarize the light because polarizer are just grating, right? That's how that's even how they draw polarizer in the first place. They draw it exactly like a grating, right?
Yeah.
Okay. So whether this polarizes angle or not, it is a polarizer. Look, it is a polarizer, right? Okay. So you're thinking, okay, this looks like a polarizer. Well, that's not wrong. In fact, you should have been thinking like that from the start. And polarizer sometimes angle itself. Fair enough. Just to be clear, is this kind of angling the angling that polarizer usually do? And if you don't know that, time to review your polarizer, I suppose.
Let me
in your note, in your note, or might as well review them. I don't know whether that's part of your exam. Is it supposed to be part of your exam? Yes. Then might as well review. Might as well. This is a good revision, right? Good revision.
There you go. Hold on. No, just hold on. Yep. And the angle change.
How does the polarizer angle change? Is it like this? Is it like that? What?
Oh, I need a better diagram than this. Doesn't it rotate like on like this axis, like the
Wait. So to answer the question, does it rotate like this or not? Yes or no?
No, it doesn't.
So use your, okay, I want you to use your finger like as the light. Use your finger as the light and point it on like in the direction of the light. Just use one finger, right? On the direction of the light, like that. Then your hand, the other hand, use it as a grating in front of the light. In front of the light. Okay, so how does the grating work? And how does the polarizer work usually in terms of, polarizing this light or whatever?
So it will turn like that, right?
I agree. Yeah, but notice that is the second polarizer. The first polarizer, just whack anything, doesn't matter. Remember?
Yeah.
The original light is not polarized. So the first polarizer doesn't matter what angle, it will polarize lah. Doesn't matter. But the second polarizer, angle to the first, that one matters lah. That's where you rotate things.
Yeah. So,
right.
Okay.
Right. So the first polarizer will automatically cut the intensity, just automatically already by a fixed amount, because non-polarized, right? Fixed amount. Then the second polarizer, depending on the angle, will cut more or doesn't cut. That's just how you study polarized, correct?
Yeah.
Okay, so is this a polarizer? It is, but is it going to reduce the intensity in the same way? Yes or no?
No, I doubt it.
Okay, currently we doubt. Okay, so I guess we put that in mind, and maybe we shouldn't go too far from that. Okay, right? In this kind of question, they do usually give you hints. In the chemistry question, remember, I asked you to go to part 3, and then the part 3 kind of give hint to part 1. Remember that? Here, I'm not saying that it's at the last part. That's not what I'm saying. I'm just saying that sometimes the question maker, not sometimes, actually most of the time, the question maker drops hint. And I feel that you should at least try to use it. I feel that you're not even recognizing the hint. That's what I feel. So prove me wrong. Where's the hint here?
Resulting differential is no longer symmetrical.
Yeah, that doesn't seem to make a lot of sense right now because that's something new, right? That's something new.
Yeah.
But that sounds like a hint.
How?
Because the usual diffraction pattern is symmetrical.
Yeah.
Right? So this is no longer symmetrical. Now, unfortunately, he asking you to suggest any other effect, right? Unfortunately, right? Oh, but if you're really into this question and you have a lot of time in exam, maybe that's a starting place, because if not, we cannot even guess. So how does that work? The resulting diffraction pattern is no longer symmetrical. How does that work, right?
How does it
become not symmetrical?
I guess it would have, the angles would be like, the angle would have changed, right? They were no longer.
The angle would have changed. Which angle? Sorry, which angle are we talking about?
The angle of diffraction of the.
I don't know, because I don't have a formula, right? There's no formula that includes this angle shift, right? So the formula doesn't directly tell me, will this change? Will that change? I don't know.
I mean, symmetrical. It should always have been symmetrical.
Yeah, I don't know why. Yeah, I'm still trying to figure out why it's no longer symmetrical. What does that mean? Means the fringe on top is wider, or the fringe on the bottom is narrower? Is that what it means? Or is that something else? I cannot tell. I cannot tell yet.
Okay.
Okay, so prevent us from wasting too much time. To prevent her, I will show you how I think about it. If you learn something, good lah. If you don't learn something, try your best to learn something. And I don't mean just learning the diffraction. I mean, see how I go back to the foundation or the old principle to make a guess lah. Now, let me state this carefully. I've never seen the answer key of this one also. Never. I am really making a guess based on things A-level student should know. You must understand it. I'm doing this pure as if I am you, although I have more experience. I don't know the answer to this. Okay, you understand me, YanKeen? I do not know the answer. I don't study TYS1. Okay, understand? I'm not quoting an answer key I know. I'm not doing that. Okay. So my first guess is, I think the slit will be narrower. I'm not so sure about this, but then again, we're guessing. Now, why do I think the slit will be narrower? Because a slit is just like a window, right? This is the window facing the light. The light is going straight like that. Now, if the window is being tilted, the window will seem smaller. At least that's what I think, right? Like the whole grating, if normal, will seem the biggest. And I mean, when you tilt it very much, the size of the whole grating is the same, but I think there'll be less and less light going in because the hole, remember the hole is like this, remember? Like you're asking this light to go through a hole, which is now like this. The hole will seem much smaller. That's what I feel like. Do you understand what I'm saying? Right. So first thing first, if you tilt it, I feel that the slit is getting narrower. Certainly that has some impact. Certainly. If the slit is getting narrower, that means you're already getting less intensity, less brightness because smaller hole, and you're getting more diffraction also. The more diffraction, I don't think matters a lot because we are already diffracting at the first place, but we're getting less intensity at the very least. Okay, so I think that already qualifies as suggesting qualitatively. Any other effect? Well, the bright fringe will be less bright because the slit will be narrower, so to speak. That's already my first guess. Okay.
Okay.
Okay, that's one. That's one. Do you understand how I came to that conclusion? And do you at least agree or disagree with it?
The slit is narrower because.
Right. So see my video. Okay, never mind. See my video. See my video. Where's my video? Is my video on? My video is not on. Oh, sorry. Yes. Okay, now I'm gonna.
I'm looking at it.
Right. Okay. Okay. So my hand is a diffraction grating. See, this is something very very bright. So this is something very convenient. Sorry, still very bright. So this is something very convenient in exam. You can always imagine a diffraction grating just using your hand, right? Yeah. Right.
Yep.
So my hand is a slit. See, here's a slit. Yeah, this a slit. Right? This is a slit. So I'm making the slit bigger, right? Now when I tilt it, the slit becomes. Can you see that? See my point? Until obviously when it's 90 degree, there is no hole. In fact, because there's a thickness here, a slit must have thickness. Even when you reach around 45, you see that it's super narrow already because of the thickness. But you know, that's my point. If you tilt a slit, it will get narrower. That's just normal. At least that's how I see it.
Okay.
Now that's something you can figure out by yourself in exam using your hand. You just kind of play around with it. We're free guessing here, so we must play around with the object. An object is there. So that's the first thing. So I was thinking, okay, maybe the slit gets narrower, the diffraction will get more, but I don't think it matters a lot, again, because it's already diffracting in the first place. I will just aim for the second effect. It's narrower, so less intensity. So the bright fringes will be less bright. That's my first answer. Okay, 2 marks, first answer. Okay. Right now, the second answer. Let's see what I can think of lah. I seem to be guessing. I am guessing, right? I am guessing. What else can it be? What else can it be? Okay. I am making a guess here, right? So I'm making a guess. So when the ray is 90 degree, the red one is 90 degree, right? When the ray is 90 degree, the diffraction will be where, so to speak, symmetrical or equal like that, right? That's just what we expect lah. Correct? I am guessing, I don't know for sure, but if the ray is not normal, then the diffraction will be a bit tilted like that also lah. That's my guess loh.
Wait, which one is the tilted?
Like the blue one is the tilted lah, right? The blue one is the tilted. The red one is the normal. The red one is normal, so my diffraction will be equally to the left and equally to the right, because diffraction simply means spreading, right? The not nice spreading, but it's symmetrical, spreading here, spreading there. Make sense?
Yeah, okay.
I'm not making any sense. Making sense, right? So blue. Now my blue is not normal. My blue is a bit slanted there. So my spreading will be like that and like that. And as you can tell, there is now more on top than on the bottom lah, because I shine it like that. That's my guess right now. Making any sense?
This is just the not symmetrical part.
I am guessing from there. Yeah, I'm trying to take the hint. Okay, so wait a minute. If I have more on top than on the bottom, then first of all, the central bright fringe is no longer there, you know? Like it will seem that I have more fringes on the top middle than the bottom middle of the screen, because my screen is still like that. My screen is still like that. That's my screen.
But how can you tell it's in the top? There's more on the top than the bottom.
I mean, the diffraction grating is a fixed thing, right? The diffraction grating size is like that. So actually, the diffraction grating is about this size, let's say, and then the screen is about that size. Sorry. The screen is about that size. Okay, Ken? And then you can already tell, if you do everything normally, the central fringe should be here, ma. The central fringe should be, right? Should be lah by right. But you're not doing that now. You're doing the blue guy. So you do like that. Let's say, and then you do like that. And then your diffraction goes like that. And the point is, the fringe is no longer symmetrical on top and bottom of the middle line. In any diffraction grating or double slit situation, you should know where the middle line is. It should be quite obvious, right?
Yeah.
Now, the middle line is no longer a middle line. I mean, I just have to say quantitatively that. So maybe there are more fringes, you know, there are more fringes on the top half and then the bottom half. And the top half fringes will be brighter, you know, or maybe the central, maybe I'll make some guesses. Like, I think the central, there's a new central fringe on top of the old central fringe. Maybe I can also make that guesses. Remember, those things are total guesses based on this lah, based on this whole thing.
Okay.
Do you follow my guesses? They are not necessarily correct, but I'm guessing like that lah. Okay. I'm not using any new method, new formula, new way of thinking. I'm just using common sense, so to speak, for the first guy. And the second one, I'm just trying to redraw the whole diffraction equation. That's what I'm trying to do. Fair, yeah? I'm purely guessing. Then we look at the answer queue. If I'm correct, I'm not happy. I'm just glad I'm not. Ready? Or is there anything else you want to do before you look at the answer?
Let's look at the answer.
Okay, so let's see what we can learn. Okay.
Superposition. boy.
Interesting. So instead of answering in n, they just give you the angle in degrees or more. So actually what you're doing was correct, I suppose. I suppose. Oh, they use the n max principle, which is fine. That's a very fair thing. You can only observe
3 of
a limited amount, right? So
yeah,
not 3. This is only 2. Yeah, only 2. So we just find those
oh
2.
yeah, 0 degrees cause the central.
That's a central bright fringe. Okay. The answer looks very fancy. Yeah, there's a formula and everything. All right.
The angle condition for maximum. What becomes okay? Sine
I have no idea where the formula comes from. Just to be clear.
I assume it's d sine theta, but I'm not sure how to go from that to this.
Yeah, I have no idea also. And I wouldn't spend time for 2 marks for this, just to be clear. Just to be clear. Right? Maybe I'll figure it out after this, maybe, just for knowledge purposes, not for exam purposes. For knowledge purposes, we can do that. Right now, we don't have time. Right? Let's read further. The fringe separation, instead of increasing with border to both sides of the central maximum, will be decreasing with order to one side and increasing to the other side. I suppose he's saying, I don't have a lot of idea what he's saying. I'm not sure. I'm not sure what's going on. Right. But he provide a graph which is telling you that he has a ready-made ideal answer. He has a ready-made ideal answer. So he's saying that the 0, that's the new central bright fringe, right? Rotated, right? The new central bright fringe is not at the original one. The 0 is now there, right?
It's moved to here, so it's higher.
Yeah, something like that. And then for some reason, the 1, 2, 3, 4 on the right is wide. The 1, 2, 3, 4 on the left is narrower, or not as wide as the original one. Looks like that.
Do they mention about
sample photo? Let's see the photo, right? Let's see the photo, right? I currently have no idea where the
I see the angle like that,
Yeah, I still don't know where the original angle is looking at this. I'm not sure what I'm looking at here, but something like that. I'm still not sure what I'm looking at here. Not sure. Right. If you are scared that the answer looks very complicated for 2 marks, yeah. I think you simply shouldn't be doing this question. You should be reserving this to the end. That's all. Because whatever guess you make, it probably won't be good enough. So just treat it for fun. This kind of question. The C part 1, I will argue that we should have been able to do it. C part 2, I don't think so.
Right.
Put it that way. Put it another way, YanKeen. If you cannot sleep because of this, that's totally the wrong thing to worry about. Just totally the wrong thing. You shouldn't be worried about this. Okay, just to be clear. Okay.
All right.
I wouldn't. Now, let's hunt for hopefully 2 more questions. We still have 22 minutes. So 2 source, okay, double slit, right? And then coherent distance, it tells us everything, right? Suggest the change. Okay, this is interesting. I think part 3 is interesting. So what happens when this right? Okay, interesting, right? So instead of writing it, we don't have much time. Just say it out or discuss it. Right?
intensity of one of the slits is reduced.
Right. Okay.
Well, but their phase difference has no change, right? So I mean, they'll still meet. They'll still meet at the same places.
Feel so? It does feel like that. Yeah. Yeah.
But the intensity of the bright fringes would be lower.
I guess that makes sense. That makes sense, right?
Yeah, but what about the dark fringes? I'm not.
Dark fringes are what?
They're not darker, are they? No, they are less. They are less dark.
Yes, they're brighter.
Yeah, yeah.
Right. Because the destructive interference is not fully cancelling.
Yeah, it's not. Yeah, it's not as.
It doesn't fully cancel. Yeah. So I think that's for 2 marks done already. You just have to phrase it properly. Okay, good. Now, second, the width of bolster is reduced. Really, they really like to, narrow the slit, right? Yeah, the previous one, they make the slit bigger. Now, this one is the narrowing slit, right? So,
okay, well, if the width of the slit is reduced, then that means greater diffraction.
Greater diffraction, yeah. That's the
So
first
it's
thing that you should be doing.
More spread out.
The fringe separation is bigger. I guess that's the guess, right?
Yeah.
Right. That's 1 mark. You should always assume that's 1 mark. Then if there's another one, that would be nice if possible.
What else?
Yeah, so I'll go straight to the point. Now, this is something I feel foundational. They don't explore enough, and also you don't therefore think about it. If it is a smaller hole, automatically the intensity is lesser.
Oh.
That's natural. If it is a slightly bigger slit, even though just slightly, obviously you're letting in more light, correct? So it's like basically saying the intensity of the light on both slits is reduced. That's also what's happening here. Does that make sense first? It's not just it's diffracted more, but it's also less light going in.
I guess that makes sense.
Yeah, because you don't think about it enough. I feel that's not what you're thinking about it. Right? So yeah. So will that give you another mark? What can you say about that? Is that something relevant? Maybe.
Yeah, I guess it is. I mean, I don't see why it isn't.
So
the intensity of the fringes are reduced, and
the bright fringes.
The bright fringes are reduced, and the fringes are more spread apart.
I suppose that's a possible 2 marks, right? Okay. Now third one. Rotation again. People like to ask this, right? People like to ask this. I'm like the first thing you have to imagine is like, what kind of rotation is this, please? Like, okay, I have to imagine first. If not, then no point. So what does that mean exactly? You have to draw something or imagine something using your hand. Either way.
What do you mean no longer parallel?
The screen. The screen. Where's the screen? Where's your hand? Use your hand. Right. Here. The slit is the. What do you mean by the screen is there? So, what do you mean by that? What do you mean by the screen is there?
I mean, I need to.
Where's the screen?
So if the screen is like that and the light coming in is like that. Oh, sorry. That.
How does what? Can you just align it to the picture, please? Instead of making a new, okay, where's the screen? Just put it on the screen, please. What do you mean? That's not the screen, that's the slit. Yeah, that's the screen. Yeah, that's the screen. You put your hand on the slit just now.
Oh.
The screen, right? The screen is there, the slit is there. Now, how does the question phrase it? He rotates the screen. Yeah, he rotates the screen. It's no longer parallel to who?
The slit.
Yeah, so is the screen currently parallel? Okay, good. Now you're rotating in a way that it is no longer parallel. Good. So at least you can imagine the question now. That's the first thing that you must do. Then the second thing is that you
What will happen?
Look, are you ready to do this? This is like the more it gets to part 3, the more it is like, oh wow, like whoa, this is getting harder to guess. It's a guessing question.
To refer back to my, as much as I have to refer back to the notes.
For now, if you want to, it's a revision, so might as well, right?
Right. Oh. I guess the positions it hits won't. The position the lights hit won't change, but how?
Look, are you making a guess right now? Are you making a guess right now? Are you referring to the notes?
Oh, I'm guessing right now.
If you're guessing right now and you're not drawing or using your hand or doing something, I'm not sure that's the right way to use time in exam lah. In learning,
I mean, I don't know what I draw beyond like this, you know.
If you cannot draw anything, then you're not ready to guess probably. I'm clear. I'm very clear about this. You're not ready to guess because you're not going back to some sort of possible principle to at least make your guess more accurate. If you cannot draw or you cannot do something to work it out, to do a working, like for example in chemistry, you're not even ready to draw the first thing.
Sorry, is it the less fringes that appear on the screen? What's this?
What's the basis?
I mean, like if it's still the same length, whatever, then it will rotate like that. Then it's like there's less like space here for the lights to hit. So I guess there'll be less fringes.
Less space?
Yeah, because like I don't know how to write it out. It's like if this is the same like say like rotates like this, right? So
no, the screen is infinite for this purpose. I'm sorry, if that's what you mean. No, the screen is infinite for this purpose. The screen is not limited. You probably shouldn't be cheating by saying that the screen is limited lah, basically, right? There's less screen to hit. Yeah, no, that's probably not. Like I said, look at the original thing. Look at the original drawing. The grating is very small. I've shown you a grating before. Wait, you might have forgotten this. I've shown you a grating before. It's just the size of the palm of my hand. That is it. And the screen is a wall, basically. It's a wall. Infinite for this purpose. Okay. Although you have some reason to there, but judging from the size of things, that's not happening. Like they even say figure 3.3 not to scale. Now you know why, right? This is more towards the scale. So I'm sorry, your guess is probably not correct. Even though it is a reasonably educated guess. It's a guess, man, right? In exam, let me repeat this. We're in crazy times. It's a crazy exam. It's a crazy preparation. We cannot even learn properly. In exam, you do part 1, part 2, you skip part 3. Simple, right? If you do this every time, you're getting more than 50%. Put it that way. Put it that way. Right. So again, we don't have much time. What do you want to do right now? I can give you some hint on guessing. That's the most I can do.
I mean, I don't just want to give up, but...
Yeah, but in exam, you do. In exam, you do.
Yeah.
In exam, you will go for other question, which shows your intelligence better than this. Because you're intelligent. Because you have studied. You're not going to spend 30 minutes on a question, which gives you 2 marks. 2 marks. 2 marks. Yeah, 2 marks, and doesn't show your ability and intelligence properly. This is showing that you can on in exam. Really no. It's showing that you cannot move on. That's not good. That's not good. Now, this situation, the only thing I can do besides asking you, just read the answer key, right? The only thing I can do is I'll give you some hints on how to guess. Again, going back to the principle. What bothers me the most is that you don't have that tendency yet to go back to the original drawing or the original way things are constructed. I feel that that's what's missing from your guessing ability, which is to say you shouldn't be guessing though, therefore until you develop that ability. Now, what am I supposed to? I'm supposed to copy the picture and then please go to page 11. Again, as I frequently say, I'm just going back to the principles that we have learned in the notes. Even though I am an engineer and I study more physics than you, I am not using more physics than you. I am not. I am playing according to the rules.
All right.
The basic thing is he does the reflection, whatever lah. Does reflection, so I'm gonna draw reflection first, and the thing died out. Sorry, yeah, my drawing pad dried out. Then I will have constructive and destructive interference, right? Something like that. I'm just trying to draw what I remember back then. It's not the most accurate drawing, right? It's not. Right? So, but the constructive destructive seems a little bit circular. It's not perfectly circular, at least I remember that, right? So, and then the screen will be hit here. So this is the constructive, and then it will be hit by the guy before that, right here, like there. So constructive, destructive, like that. Constructive, and then there's something between, right? So the screen is being hit by this consecutive thing, something like that, which represents the constructive interference, kind of something like that, right? This is the first thing that they ask you to the draw for you. They don't ask you to draw; they draw for you. But this is what happened. So I have your first, second, and third theme. Now I apply the same thing because what exits from the slit are the same thing. The screen kind of changes, right? The screen kind of changes orientation. So I'm going to imagine what is being, what is hitting the screen based on the previous wave I am drawing. That's, I think, the best thing I can do for me. If I have time, I will do this. Then I try to answer from there. So let me repeat one more time. You don't get what I'm drawing, right? You don't get it, right?
Well, there's only one wave. There's supposed to be like two. But or is that the?
Which one are you asking? I have no idea.
I like the wave fronts.
You should use the laser pointer or something, right? Yeah.
Like the wave fronts, and there's supposed to be two wave fronts.
Aren't there supposed to be two wave front? Oh yeah. So here's the first wavefront, right? So if you want to, I'm drawing there, but I'm not interested in drawing the wavefront. I wasn't drawing the wavefront. I wasn't. I wasn't. This one is just the diffraction direction roughly, and then what I'm doing is the area of constructive interference. I'm drawing that. I wasn't drawing the wavefront.
Where they constructively interfere.
Oh my goodness! Open your note. Open your note. If you don't get this, you cannot. There you go. There you go. Oh, your note doesn't draw that. I'm sorry. Your note doesn't draw that. I'm sorry. Your note doesn't. Your note just draw the two wavefronts. My apologies. So I'm going to try to copy your note and see what I'm doing. I'm going to show you what I'm doing. I'm going to show you that. Don't cover it. Don't cover it, please. Don't cover it. Don't cover it. Yes, thank you. I'm going to show what I'm doing. Sorry, slightly different note. Apologies. Should have started from your note. I don't have a drawing pad. Let's just. Draw. Yeah. Okay, so what I'm doing is I am, let's say this is constructive, right? Now this is I'm gonna connect it with this. Oh, wait. So, yeah, that looks about nice. Yeah. And then this is constructive also. This is constructive also. It's constructive also. Oh, I will be confusing you, right? No, I have to do it. So I'll just do it just one second. So this wavefront, with this wavefront is not exactly the wavelength of the light. The wavelength is smaller. That means he's drawing less wavefront than what could be possible. Does that make sense? That means there's another additional wavefront here, one in the middle here. Definitely there is. Because the wavelength is very small. So there will be more wavefront. There will be a lot of densely packed wavefronts. Make sense? Am I making any sense or no? Doesn't make sense.
I mean, there are more wavefronts. Yeah, I can accept that. I mean,
He's drawing it rarely to show you better, if that makes sense. That makes sense. But there's definitely more. So let's say I'm drawing more. So here I add one more here. Say I add one more here. I'm trying to follow. Okay, see, I draw one more here. And then, oh my goodness, that's very ugly, but I'm going to draw one more here. One more here. Just two more. Just two more. Yeah, two wavefronts, right? Like immediately, I am getting more constructive interference points already, right? And they are there, they are there. They are there. Definitely there. Okay. So as I draw more and more of this, I can draw something else. I can start to connect the dots better. I can start to connect this dot and this dot and the dot here better because there are more dots here. As I start to connect their dots, I see a connection between the possible constructive interferences. That was what I'm drawing here. I apologize. I didn't follow your note. Your note doesn't go there. Your note does it here. I think it's
the points are more.
The constructive points can be imagined to connect. Can be imagined to connect, so to speak, kind of ish, something like that. If you draw enough wavefront, which is obviously we cannot do that.
Oh.
And there are definitely more wavefronts. It's definitely right.
So you're connecting all the points at which
of the constructiveness, the points of. So it makes it. That was right, and I make it easy for me to kind of imagine what happens when the screen. Now, in let's say we follow your notes case. Let's say you draw this. Let's say you draw this in exam because you have a lot of time, right? You want to figure things out, and then you kind of draw the screen like that. You just have to imagine the existence of the additional points to kind of imagine what happens to the fringe, I suppose, right? Now let's go back. Time is short, right? If this is something totally new in exam, this is the minimal amount of work to guess correctly. You go back to this foundational drawing. You know what the foundational drawing means, and you alter the screen in the foundational drawing and figure out what's going to happen. That's, I think, the minimum work. If this is totally new, as you can tell, this is a lot of work, especially in exam. Fair?
Mm-hmm.
So it is not worth the 2 marks. It's definitely worth when you finish every other easier marks. Definitely. Secondly, I don't think you can minimize the work. I don't think I can. I don't think you can minimize the work needed to guess. I cannot. At least I don't think I can. I don't know how to teach you how to minimize the work. This is the minimum for a challenging question. This is like an MCQ where you have to do a lot of work, like some MCQ are just straightforward. Some MCQ is just, what the heck, man? I spent 10 minutes, I'm not sure. This is that kind of thing.
All right.
Okay. Right? That's just how it is. Okay, but remember, your first 4 marks, using your basic knowledge, I think you guessed quite well. I think you guessed 3 out of 4. I have to give you the hints for the 4, but other than that, it's okay. Sorry, no easy answer for guessing questions. I'm sorry, that's just how. That's just how. Right now, what do you want to do right now? You have 2 more minutes.
I mean, should I check the answers? I mean,
you should always check the answer key. It is a crazy time. You should always do that, right?
Proposition. Yep, the contrast between the reduced bright fringes and bright
Nice. Right, nice. Okay, excellent, right? Excellent. Then you have the drawing, whatever lah.
More fringes to reduce due to greater diffraction. Okay. Contrast will also decrease. Yep, there was less intensity.
Yeah, there's no change in fringe separation. I'm very surprised about that.
Fringe separation will no longer be uniform. Yep.
Oh, he's drawing that actually. He's actually drawing that. He's drawing something kind of like that. He's actually kind of drawing something like that. He's tracing the path of constructive interference in a different way lah. Those lines. He's actually tracing that. He's actually tracing. Your note doesn't go into that detail, I suppose, but those lines exist.
The fringes nearer the slits will also be brighter. Oh, what?
Because it's closer, ma. This part is the part that you don't get very well. If you see a lamp closer to you and further from you, the lamp brightness changes what?
Oh, I guess, yeah.
Because if the lamp is further from you, it has already spread more. So the light hitting you is less intense because it spreads more.
This is like a. I guess not. I guess not because it diffracts, right? I thought. Yeah. Okay.
Yeah, the spreading is due to diffraction. You still cannot deny the fact that if it is spread less, that means it's nearer, ma. It spread less, so it's more intense lah because it is spread less, right? It's nearer, it's spread less, so it's brighter. Totally fair. Right. Something they cover more in the quantum physics. For some reason, that's what they focus on. So just treat it as a bonus. Now, even the answer key bothers to draw things, is what I'm trying to say. It's very rare for the answer key to put in a new formula like the one just now. Like very different. Like that's just very rare. Normally, qualitative questions like this, guessing questions are qualitative questions, they draw. You should take it as a like if this is totally new to me and I want to engage this question, I should be drawing something. If I cannot even draw something, get a clue and get a hype. Just go away from the question. It's not for you. I'm talking about like Tuesday. I'm not talking about A-level. Right? I'm not talking about A-level. A-level, I think we have time to try a lot of things, right? Tuesday, get a hint and just do other question, right? That's it.
Right.
That's not called giving up, Giving up is when you have half an hour left and you don't do anything. That's giving up lah.
All right.
Okay, I'm not asking you to give up. That's just wrong. I'm asking you to show your intelligence in the best way possible.
Okay.
Okay. Yeah. Okay. Right. Okay. Now, when we meet on Tuesday, what do we do?
Definitely.
Right. I expect that you have 100 questions for chemistry, or you have read the answer key and then note all the questions that you don't understand, right? That's the minimum that you must do, even though you just had your physics exam. I don't care. The minimum you must have done is that you have 100 questions. or read the key and hunted for questions, either one. Understand?
Right.
That's for Tuesday. Now, oh yeah, we are not meeting tomorrow. So even though that's because it's only 45 minutes, you must have done that. Okay. You can hunt them during class. You can do that. You can ignore the current subject a little bit for a while. You can do that. Crazy times, right? Crazy times. Crazy times, crazy things. You cannot do both. You are still trying to do both. That's what I feel. You can't. That's crazy. That's craziest if you think that you can do both. Right? That's nonsense. That's nonsense. If you think you can do both. I cannot do both. I can't. Okay, YanKeen?
Right. Okay.
Right? Crazy times, crazy times, crazy things. Right? So do the crazy stuff. See you on Tuesday. And if you have asked any questions during Monday, I'll be glad to answer. Okay?
All right. Okay.
Bye.
Bye.